Hi, my name is Chris Peters. I'm an end-user product marketing manager with Intel Server Product Group. And today we're here for section 3 of our 3-part series on virtualization. And I'm here with Radha Krishna from our Server Advanced Technology team. And what we're going to be talking about in this session is what is Intel doing to support virtualization? Do you meet with IT folks about what they're looking for from their virtualization environments?
Actually, two kinds of customers. One of them who is looking into actually how do they do virtualization, and the other people who have deployed virtualization in the model of consolidation, and they are looking into much more flexible data center kind of an application with virtualization.
What is Intel's role in virtualization?
Intel is putting in what we call as hardware assist, that is features within our hardware across the platform, within the processor, within the chipset and the networking devices, essentially to make implementation of virtualization simpler and to reduce the overheads of the VMMs while running in a virtualized environment.
And where does the end user end up seeing from that overhead?
What the end user or the IT manager sees essentially with the overheads is lesser performance. We are able to do a lot of things in the hardware that actually reduces these kinds of overheads. The things such as VT Flex Priority available in our processor increases the performance of 32-bit operating systems by approximately 35% and improves the boot time as well by 40%. So we have technologies in our networking devices which can actually offload the VMMs from doing certain tasks such as sorting of data and grouping of data. So you see better performance on the application side and also greater throughput because now the hardware is doing work that the software would have done otherwise. One of the key things about these kind of new usage models, which we call as Virtualization 2.0 here at Intel.
2.0?
Yeah.
Why 2.0?
It's beyond the initial phase of virtualization that everybody adopted virtualization for, which is consolidation.
Oh, so 1.0 is consolidation and 2.0 is...
usage models that are beyond consolidation, such as load balancing, high availability, disaster recovery. And as people have taken advantage of consolidation, they now see that they have resources within the data centers where they could flexibly deploy their VMs or their infrastructure in a better manner to take advantage of all the resources that are available in the data center. Some of the key technologies that we are bringing within the hardware assist is essentially targeted for that. So one of the features that we recently have provided in our hardware is known as Flex Migration.
How does that work?
It basically allows the hypervisors to expose a consistent set of instruction set across any generation of servers that it is controlling within the resource pool.
How does it do that?
What happens with Flex Migration essentially is if you bring in two servers together of different generation, then the hypervisor can go in and make it look like the previous generation server, so that the instruction sets that are available to the application in server B is very consistent with what is available on server A. Things such as performance available through better cache, through better process technology like 45 nanometers are totally not impacted by any of these.
Okay.
So you're going to see better performance with the new servers while they will coexist with the previous generation servers in the same resource pool.
In these flexible live migration models, was the impact on the network?
Virtualization itself has an impact on the networking. There is also a requirement for centralized storage. So if you look at the usage models of load balancing or high availability or disaster recovery, all those work on the premise that you have a resource pool and they are connected to a centralized storage. So there is an impact towards both on the LAN as well as the SAN.
What specifically, from a technology perspective, is Intel doing to enhance that environment?
Intel has a 10 gigabit Ethernet networking devices, which incorporates technologies, particularly for virtualization, to offload some of the VMM overheads so that you can do higher throughput. While our 10 gigabit Ethernet with a networking technology known as VMDQ can perform up to 9 gigabits per second of throughput compared to if you had only software-only solution, you would be limited to only 4 gigabits per second.
It's a pretty dramatic jump.
It is more than a greater than 2x improvement in throughput, while also you get CPU cycles back for the applications to run because you're reducing the VMM overheads.
With hardware assist, the software and hardware have to be working together. So who's Intel working with when it comes to making sure these hardware assist features are enabled through software?
Intel has been working with most of the predominant vendors within virtualization, whether it's VMware, Microsoft, or the Zen open source. We are contributing actively to make sure that all these solutions, the software that is out there, actually enables all these new hardware assists.
So in summary, it sounds like Intel's doing a lot at both improving the base platform as well as hardware assisting the server environment across the network.
Sure, and also working with the ecosystem to make sure that the software and solutions are available for the hardware that we bring to the customers.
Virtualization is one of the most exciting and interesting activities that's happening today within IT. Thank you for joining us in our session today. We'd like to invite you to participate or learn more at Intel.com.